So good morning friends. Today I am going to discuss about the lambda max values for the given compounds. Okay. So I already gave you the basic concepts of homoannular diene, heteroannular diene, and then exocyclic double bonds, double bond extending conjugation and ring residues. Now we have to use those values to calculate the lambda max values for the given compounds. Okay, fine. Now first observe this compound. Once you observe this compound, then this is nothing but your heteroannular diene. See, just observe this part. So this is your heteroannular diene. So the base value for heteroannular diene, is equal to 214 nanometers. Okay, then please follow the same sequence. Then next, exocyclic double bonds. Exocyclic double bonds. See how many exocyclic double bonds are there. See here, this is ring A, this is ring B. Now if you write the ring B, this is ring B, and then here you have a double bond. So therefore, now this double bond becomes, this double bond is exocyclic. This double bond is exocyclic to ring B. And I already told you that for each exocyclic, the base value is 5 nanometers. So you have one exocyclic double bond is there. So it is 1 into 5 nanometers. That is equal to 5 nanometers. 5 nanometers, right. Then you have to go for the ring residues. You have to calculate the ring residues. So observe carefully that I already gave you the concept. Again I am repeating here. See, whenever you have a double bond, the double bond should be attached to an sp3 carbon. See, once you have an sp3 carbon attached to double bond carbons, then that becomes a ring residue. It is like this. So this becomes a ring residue, this becomes a ring residue. Now draw this molecule again. Now if you draw this molecule again, say I am writing a little bit big structure here, so that you will know the ring residues very clearly. Okay, fine. See here. Now for this double bond, see, for this double bond, now this is sp3, this is sp3 carbon, so this becomes one ring residue. Again here, this is attached to one, this is sp3 carbon, so this is one ring residue. Now this is attached to sp2, this cannot be ring residue. Again come to here, this is attached to sp3 carbon, this is sp3, so this becomes a ring residue. So there are only 3 ring residues are there. So therefore for each ring residue the base value is 5 nanometers. So 3 into 5 nanometers, that is equal to 15 nanometers. Over, your answer is over. So just add it, 5 plus 5 10 plus 4 14, and then 2 3. This is 234 nanometers. 234 nanometers. So first example is over. Then let us go to the second example. Now if you observe carefully this molecule, now this becomes a homoannular diene. So this is your homoannular diene. So the base value for homoannular, diene, that is equal to, so this is base value for homoannular diene, as I already told you, this is nothing but 253 nanometers. Then you have to go for exocyclic double bond. Exocyclic double bonds. So exocyclic double bonds, so just write this, this is ring A again, this is ring B, just write this ring B here. So you have a double bond here, this is ring B. Now this double bond is exocyclic. This double bond is exocyclic to ring B. So you have only one exocyclic double bond. So for each exocyclic double bond, the base value is 5 nanometers. So therefore 1 into 5 nanometers, that is equal to 5 nanometers. Over. Then what you need to do, you have to calculate the ring residues. You have to calculate the ring residues. Okay, again I am writing a structure, a little bit big structure I am writing here. So then that will be very clear for you to calculate the ring residues. So you have one double bond here, you have another double bond here. Now if you observe this double bond, see here, this is the sp3 carbon, this is sp3, so this becomes one ring residue. Now coming to this, so this becomes sp2, so this is not ring residue. And then coming to this, so this is attached to, this is sp3, this is sp3, so this is one ring residue. This is another sp3 carbon, so this is another ring residue. So therefore there are 3 ring residues are there. So for each ring residue, as I already told you, the value is 5 nanometers. So 3 into 5 nanometers, that is equal to 15 nanometers. So add these two, 5 plus 5 10, 10 plus 3 13, 6 plus 1 7, this is 273 nanometers. Over. Second example is over. Now come to third example. Again, see here. Now the base value, this is a homoannular diene. So the base value for homoannular diene. So the base value for homoannular diene. So the base value for homoannular diene, as I already told you, this is nothing but your 253 nanometers. Over. See the second one. Second one is your exocyclic double bonds. Exocyclic double bonds. Within brackets. See here. Now for exocyclic double bond, see here. Again, so this is the ring A, this is ring B, this is ring C. Now for ring B, I am writing the structure of ring B here. So you have one double bond here, you have another double bond for this. So this becomes the ring residue. This becomes the exocyclic double bond. This is exocyclic to ring B. This is exocyclic to ring B. That's it. So for you have only one exocyclic double bond. So therefore this is 1 into 5 nanometers. That is equal to 5 nanometers. Okay, then next you have to calculate the ring residues. Calculate the ring residues. So if you calculate the ring residues, see here. Now if you observe carefully, see this double bond. So this is sp3 carbon. So this becomes one ring residue. And then now coming to this double bond, so this is sp3, so this becomes another ring residue. This is sp3 carbon. Now coming to this double bond, now this double bond is also attached to another sp3. Okay, so there are 3 double bonds attached to 3 sp3 carbons. So how many ring residues are there? 1, 2 and 3. So for each ring residue it is 3 into 5 nanometers, that is equal to 15 nanometers. And here you have another one is there, that is double bond extending conjugation. Double bond extending conjugation. Double bond extending conjugation you have. See, for each double bond extending conjugation, the base value is 30 nanometers. Now if you observe carefully, see this is a homoannular diene. Now for this homoannular diene, this is the double bond that is extending conjugation. So you have one double bond that is extending conjugation. So therefore 1 into 30 nanometers will 30 nanometers. So add all these things again. 5 plus 5 10 plus 3 13. 5 plus 1 6 7. 7 plus 3 10. And then 2 plus 1 3. 303 nanometers. 303 nanometers. Okay. Over. Then now coming to the fourth example. Now see here. Again this part is nothing but your homoannular diene. So the base value for homoannular diene. The base value for homoannular diene. That is equal to 253 nanometers. Right. And then you have exocyclic. Once you have the concept, then everything is very clear. Exocyclic double bond. So exocyclic double bond, see here. Now if you observe carefully, this double bond is exocyclic. This is ring A, this is ring B, this is ring C. Now this double bond is exocyclic to ring A. That means ring A is like this. See here, this is ring A. This is ring A. You have a double bond here. So this is exocyclic to ring A. Exocyclic to ring A. And similarly you consider this ring C. You come to ring C. This double bond is exocyclic to ring C. Exocyclic to ring C. Over. So there are two exocyclic double bonds are there. So you have 2 into 5 nanometers. That is equal to 10 nanometers. Then you have to calculate the ring residues. Ring residues calculation is very easy because I already told you the concept. Now see here, this double bond is attached to sp3 carbon. This is sp3 carbon. So this is sp3 carbon. So therefore this is one ring residue. And again, now this double bond is attached to this. So this is a ring residue. Now coming to this double bond. Now see here, this is attached to, this is one sp3 carbon. And this is another sp3 carbon. So this becomes a ring residue, this becomes a ring residue. So 1, 2, 3, 4. 4 ring residues are there. So now you have 4 into 5 nanometers. That is equal to 20 nanometers. And then you have, see, for this homoannular diene, this is the double bond extending conjugation. So now double bond extending conjugation. Double bond extending conjugation. So you have only one double bond is there. So 1 into 30 nanometers, that is equal to 30 nanometers. So add it. So 3 plus 2, 5, 6 plus 5, 11. This is 313 nanometers. Over. Your fourth example is over. Fifth one is very, very simple. This is a very, very simple example. See, if you observe carefully, so that is nothing but a heteroannular diene. The base value for heteroannular diene. Base value for heteroannular diene is equal to 214 nanometers. Right. Now no exocyclic double bonds. So you have ring residues are there. See the ring residues and now it is very easy to calculate the ring residues now. Now this is the double bond. Okay. This is sp3 carbon. So this is one ring residue. Similarly, this is another sp3 carbon. This is another ring residue. Similarly, this is sp3 carbon. This is another ring residue. This is sp3 carbon. This is another ring residue. So let us, it is like this. That means it is like this. See, you have one carbon, you have one carbon. This is attached to one carbon. This is attached to another carbon. Okay. So therefore, this is one ring residue. This is one ring residue. This is one ring residue. This is another ring residue. So 4 ring residues are there. So 4 into 5 nanometers is equal to 20 nanometers. So altogether you have 4, 2 plus 1, 3, 234 nanometers. So I will discuss more examples in the next video. Thank you.